Hello, everyone. I hope you're enjoying Push2PROD. This is Turbonomics session, Managing Kubernetes Performance at Scale. And my name is Eva Tutsai. I'm with the Advanced Engineering team here in Product Management, and allow me to introduce one of my favorite people here at Turbonomic, Enlin.
Thanks, Eva. Hi, everyone. This is Enlin Xu. I'm Engineering Director at Turbonomic. Nice to meet you, everyone, virtually.
And during this session, please remember to use the Q&A and chat options. They are located in the bottom of your screen. Enlin and I will try to get to your questions. There'll be someone else from Turbonomic also ready to jump in if we can't. So let's get going. So I want to start out with the context here. Cloud native applications, they're great. They help you solve the challenges of monolithic applications to achieve faster time to production, reduce the risk, and also get cloud economics. So all of these are great things about cloud native applications. Somewhat simple to develop. I think Enlin may have some opinions around here, but I think relatively simple to develop, at least simple to innovate on, but complex to operate. And as much as we have great Kubernetes here on this session, just saying techie things does not solve the challenges of how to achieve all those benefits of cloud native applications. One of our favorite Dilbert cartoons here. So what is one of the problems of assuring performance of these containerized services at scale? Well, the first challenge is what we like to call the multi-tenant butterfly effect. Multi-tenants are complex. I mean, even if you have a single tenant in your cluster, these applications can have multiple services that could be split up as separate tenants or namespaces or projects within these clusters. So what's one of the challenges? Well, the developer is going to deploy their services. They may have to very likely put in a container specification, and they'll may not want to spend a lot of time trying to figure out how much services actually need. So they may request more resources and hope that it fits within their quota. Now, the butterfly effect is someone may be looking at these specifications coming through the pipeline and saying, okay, in order to deploy these services, we may need to scope the project for a certain amount of quota, which may need more nodes. And then the engineers that are providing the underlying compute resources, they're going to be saying, okay, well, we need to provision more resources, even though I'm not sure why, because the utilization overall looks pretty low. And someone says, whoa, what's going on with the cloud bill, right? I thought we were running micro services, not macro services. And the reason we get into this kind of challenge and this butterfly effect is there's risk in running multiple applications in a single cluster. This is a manageable risk, the risk of some services consuming more resources than others. That may be fine, but these containers, they're ephemeral things, they're wild woolly creatures. How do I manage the trade-off of a changing dynamic environment and also more and more application tenants onboarding? So we play the quota allocation game. If I give you a quota, this is a bucket, you use what's in your bucket, then I can determine how many buckets I can fit into this cluster. However, it's still all a guessing game. And even though you try to mitigate this risk of assuring performance, the downside of the allocation game is you really don't understand each tenant's demands. You don't know how to action on fluctuating demand, except when a tenant tells you they need a bigger quota. So driving allocation models drives over provisioning, and you still can't guarantee performance. This is all hard because microservices themselves are complex. You move away from the monolithic application for good reasons, but now you've got all these different services. There can be congestion at any point through this stack of interdependent services, but also underneath the infrastructure that can bubble up into performance issues in the application. So managing the end user experience or the performance of these services becomes complicated. What do you do there? Well, we have observability tools that will tell you, okay, red light, green light, and all sorts of metrics that the app teams and DevOps teams can look at. But none of these tell you what you should do. So you rely on human beings in this pipeline of managing applications to make resourcing decisions. Well, to really manage a Kubernetes performance at scale, you need to let software help you make actionable, automatable decisions. And it must start out with making the complex simple. Start out with taking these microservices and representing the full stack of dependencies and the context of where resources are coming from to service not just the application or the tenant, but to service each one of these microservices. You need visibility from the cluster through the platform down into the service. And you have to say no to thresholds, no to manual policies, no to guessing, and yes to actions. So how do you get here? How do you get here in actionable decisions through the layers, whether you need to understand how to scale out application resources to avoid SLO issues? How do you size your containers? How do you dynamically place pods so that you mitigate congestion at a node? How do you manage underlying infrastructure? Well, that starts with the right types of analytics. Enlin, you've been here at Turbonomic for 10 years, right? I think you probably can talk to the right type of analytics the best.
Yeah, sure. So as Eva mentioned, so what changed? So this 12-factor application of cloud native application, this kind of revolution is driving this whole containerization or microservice in the industry. So basically, everything is easier for develop, but it's more complex to operate. That's what happened across the industry. And what we talk about operation is more like the data operation that we are describing. So your life cycle, your application life cycle, or your cluster life cycles is not just bring your customer, bring your tenant on board, and that's it. Let them do whatever they want. You need to make sure that the application is performing, get the resource when they need it, and every layer they have their own compliance that you have to satisfy. So what Eva shows here about how do you continuously assure the performance, ensure compliance, and lower the cost is what we are trying to help with. And especially in a containerized environment, when you're facing a higher density and more layers to manage when you run these containerized workload inside a virtualized environment, you definitely need some automation software to help you manage all different knobs that you can manage for your microservices.
Right, so Enlin, I think what you're also saying here is that to effectively manage this density of different components, managing the trade-offs and that little animation down there, that's trying to visualize that the trade-offs can change as the demand and the supply of demand for resources and supply of resources can change. So I'm guessing this is not a one-time thing that you just determine a few actions that you can take and everything just all of a sudden gets better, right?
Exactly. This is very true, especially even if, let's say, even if the developer himself does the perfect job to size every single container he can, as much as he can, in the end, when you deploy everything into production, it's going to be a multi-tenant environment. like you showed earlier, the multi-tenancy is going to be very complex. Different people may have their own autoscaler that can grab the resource that you don't even know when it will happen. So in this case, how do you continuously managing the trade-off among the three dimensions you show here is extremely challenging.
In fact, yeah, let's actually dive into some of these dimensions and some of these actions. So you said this too, Enlin, right? That every one of these services could deploy with some sort of resource specification. And sometimes that's dictated by the fact that if you have a quota, now every service has to have a specification that aligns to that quota object. So now you have to have size. And how do you know what the right size is, right? Enlin, is that one of your team's favorite things to do when they're building microservices, is to figure out what size it is?
Right, so if we just look at Turbonomics, so we are building an automation platform to help people to manage their workload at different sizes, depends on their size of data center. Some of them running everything on cloud, some of them running everything on-prem. But if you think about it, some of our customers may have only 1,000 VMs total, but some of them may actually have 1,000 AWS or Azure subscription, which contain tens of thousands of VMs. So definitely you don't need the same size for these two customers. You definitely need different resource stack for all these components that composing Turbonomic to support different sizes. This is exactly why we need a continuous system that continuously trying to help sizing these containers in real time to make sure that we are not sizing too much or we are not sizing too little, that you may experience some OOM kill from time to time.
Right, right. And then Kubernetes is a great orchestration platform. And the scheduler does a great job in initial placement of these services, right? Initial placement of the pods. What's interesting about that is that if you think about pods as cars and nodes as lanes of traffic, and when there's traffic or congestion, maybe, and then I'm not sure about you, but all right, I admit I have a little bit of road rage. I'm not driving too much now though. I'm staying put pretty much, but when I get on the road, I would definitely take advantage of an open lane next to me to move into that open lane and to try to get around the cars in front of me because I'm focused on my destination, right? What's interesting about containerization is there isn't a way automatically to move between the lanes. If there is open capacity on this far right-hand lane here, the only way to leverage it is something's got to evict or kill that pod in the other two lanes. That's not really a good experience for a user, nor is it a great way to manage avoiding traffic in the other lanes. So the other key element here is in the theme of continuous optimization and continuously managing the trade-offs is continuous placement. And then do you want to describe a little bit about the rescheduling that that your team has been able to extend in the Kubernetes platform?
Yeah, sure. So basically, if you look at the Kubernetes scheduler, so basically it relies on the requested resource on CPU and memory to decide what is the best place at this moment when you request a scheduling event. What is the best node to fit this pod based on your request specification in your YAML file. But in reality, especially in a multi-tenant environment, things can change all the time. Especially the ignored part is the consumption. What is the real consumption of the underlying node? What is the consumption of yourself? And what is the consumption of your neighbors, that we call noisy neighbor? What if like all of a sudden your antivirus software or backup service start to running and get all the resources and you're not able to get the resource that you're supposed to be burstable. So in these cases, like having the capability to looking at the real-time consumption at the pod level, at the node level, and making sure that we always try to bring the pod to the best node at any given time, not just the scheduling time, is what we call rescheduling. So basically it helps us to find out that making sure that you are always land on the best node possible for these pods that can be moved, and making sure that everything can be performed. So this is on the performance side. From the efficiency side, we can also, by moving these pods around, we can consolidate the workload and defragment the resource in your cluster, and helping you to shut down nodes that you don't need, basically.
So you're right, Enlin, that to manage all of these, to manage the changing nature of more tenants onboarding and to manage the changing nature of the performance of your services, you need to be able to have also an elastic underlying infrastructure to understand what are the optimal number of nodes that you need, understand how application-driven demand can change the time that when you need to scale out or scale in, and not to just use CPU and memory thresholds, because optimizing the size of the service, continuously optimizing placement of these services all lead to an elastic infrastructure. So with that, oh, and of course, you need to understand the benefits of taking these actions, and you need the analytics to show you that. So in one of our test scenarios here, if we consider the benefits of continuous placement and reducing requests when they're not needed, but also sizing up for services to prevent those performance issues, if we can reclaim some headroom safely in a cluster, you can use this for deploying more applications with confidence, for giving resources to the applications that need it when they need it, and maybe even less nodes, right? So with that, why don't we go to the demo? I'm going to stop sharing.
Hi, can you see my screen?
Yes.
Great. So thanks, Eva. So this, I'm going to do a quick demo on what Eva described to give you a real thought about like what real feeling about what we are talking about, including like the full stack visibility, and then the continuous right sizing of your containerized resource, as well as continuous placement for the pod over the best nodes in real time. So basically what you're seeing is the landing page of Turbonomic. So you can see like we give you a single pane of glass of what whichever Kubernetes cluster you're running on top of wherever the IaaS infrastructure you're running. So to achieve that, all you need to do is basically add a license, of course, and then tell us a little bit about what flavors you're using across your data center. So as you can see, we do have like different vendor support across each of the layers that you're using for a data center. Almost all the major vendors, we have the out-of-box API support. So you don't have to drop an agent, and we do support all these layers. So all of these target, basically, you can see here in my demo appliance, I have a vCenter environment, and also I have a AWS subscription. On top of that, I do add 3 Kubernetes clusters for my QA, prod, and dev, and all 3 of them actually are running on my vCenter environment. So what you're going to see is all these targets provides you a snapshot of what your environment looks like. This is the global view of your entire data center that added through this target addition view. So from the global view, this donut chart actually can clearly tell you by color coding that what are the risks that we are talking about in terms of performance, compliance, and efficiency that Eva described as the trade-off engine that runs continuously. At the current time, what are the things you can do? So the yellow indicates there's efficiency, opportunity to improve the efficiency. The red means you have performance risk. you may experience some out of memory if you don't do anything. And this can happen on every layer, as you can see, because in every layer you may see noisy neighbor. For example, from the node perspective, you may have noisy neighbor on the pod. From the host perspective, you may have noisy neighbor for VMs. From the storage perspective, you may have storage on the same disk array, maybe a noisy neighbor as well. So now you can actually choose to zoom in based on, for example, whether you're an IaaS focused engineer, or you're actually a tenant ops focused engineer, or you're actually application owner. You can choose, like, for example, I'm focusing on the entire cluster. Then I zoom into my cluster. This is my Kubernetes prod cluster. You can see there are total 7 VMs, and 5 of the VMs are running fine. One with critical risk, and 1 actually has minor risk. But if you just looking at the optimized view that we actually show you before and after our actions, in fact, even though some of the, you can see a clearly non-even distribution of the workload, some of the nodes are actually running high on CPU. You can see there are 2 VMs. That is exactly there's 1 VM is running like 93% of the CPU utilization. And if you actually apply all the move actions that we recommend you to do over time, you can actually see, like, not only we solve the high CPU spike on this particular node, we actually think that you can suspend one of the VM because of this defragmentation. So if you look at these actions, all of these actions you see here is actually action executable. You can apply any of these actions and just do apply selected, and they will be moving the pod from the VM original node to the destination node. Help you to address the vCPU congestion that experienced on this particular node. So you can see multiple pod is actually about moving from out from this node into another node in the same cluster. So by having this continuous placement functionality, you don't have to worry how the fluctuation looks like over time on the pod layer as well as on the node layer. So our engine automatically help you to find out what's the best placement for the pod, how to avoid noisy neighbor, how to defragment resources by having this powerful continuous placement capability. Eva, did I miss anything?
No, Enlin, no, I think this is, in fact, this is a great view for someone in a DevOps role, right? This is kind of typically what our DevOps user is interested in, is managing at this, ultimately this cluster level. And then probably this is what you're going to do next is, now how do I give a perspective to all of my tenants, right?
Exactly. So if you scroll down, you can see, like, this is, it gives you the overview of what the opportunity to move your pods between the nodes to achieve better performance, or actually some of the action of move is actually, we think this node, specifically the node is suspendable, that you can improve your efficiency. So when we also move your pod around to achieve a better efficiency to scale down your cluster. So if you keep scrolling down, you can see, like, we also have, like, top view of the top container in the cluster, top virtual machine, as well as top namespace. I think based on our experience with customers, namespace is basically the onboarding unit for internal customers to get down your Kubernetes cluster. So if you look at the namespace view, you can see, like, among all my namespace, this Rob shop obviously is using a lot resources. You may actually using t-shirt sizing when onboarding people. Now, after everyone has the namespace to use, after some time, you may want to take a look, see who needs more resource and who actually doesn't need that much of resources. So you can then zoom into the particular namespace, see what happens in this robot shop. So if you click on this namespace, all you're going to see is these are all the deployment or stateful set or daemon set runs in this namespace, and and then together with this is all the container and the container pod running inside it. If we click on the container, you can see all the actions that we are able to recommend in this namespace. Some of them is actually about, for example, this container. It's running extremely high CPU and memory. Basically, this one is running extremely high CPU. So we tell you that you should actually resize up your CPU limit. And if you go back, you can see there are also more actions about the resize down. So there's actually a lot of container that is misconfigured on the CPU memory limit or as well as the CPU memory request. So by having this capability, basically how we achieve that is you can actually control our behavior by coming to our policy and tell us, so we use percentile-based resizing, so you can tell us how aggressive you want to control your size of container, what is the main observation period and max observation period, which could be corresponding to your cadence of your service change and management control. So by controlling this, you can actually tell us what the changing window looks like, what the cadence of the changing window, and we will be able to adjust that and making sure that our change accommodate your changing window, and you can actually use this to guide what the behavior should be. So back to you, Eva.
Yeah, and actually before we leave this, I think one of the other principles here in the full stack analysis that you mentioned, Enlin, is that resize up action is taking into account the namespace quota. So we will not only respect the quota, but we can also make this actionable because we understand the available supply of the underlying infrastructure. Because this is important.
Yeah,
I'm sorry.
Yes, that's a great point. So basically all these actions you see here is basically taking to consider whether your quota has enough capacity, enough headroom left, and whether your node is also having enough, for example, request resource left. So all these actions is taking that into consider.
And history too. You have a reflection here that since pods are very ephemeral, we can retain the history of a service or a deployment or whatever type of workload kind that you have, right? There is,
yep.
That is what I like to call our little four corners of optimization here, is that we still reflect the ephemeral components of the running pods and containers, but now we're going to give you history of every instance of the replica set that ran for this service, and it's all right there for you, that you can see the history of this service, what it was using, no matter how many times a pod could have restarted.
Exactly, and in fact, if you feel like you need more time to actually automate these actions that we recommend for size up, size down, scale up, scale down your cluster, or move your pod around, you can also leverage our what if engine to run a plan on top of your cluster. For example, I pick my prod cluster and I want to take a snapshot of it and run a plan which basically runs a what if engine to show you, like, what if you execute all the actions that recommended by Turbo, how will my environment look like? So in this case, as you can see, you can actually suspend one virtual machine as the node to scale down a cluster and still satisfy your demand. And
right.
You can actually also remove one host that will improve the density on the host side. And this is basically what kind of action you need to do. And before and after, looking like the cluster still, you can see like we remove the peak of the particular node, and we are able to suspend one of the nodes in your cluster. That still satisfy your demand on the container perspective.
Excellent. And again, this is possible because we're doing this multi-dimensional analysis. It's doing the trade-off. It's not about trending one metric and then putting a threshold on it, right?
Exactly.
Okay, thanks so much, Enlin. And I think then just to finish this off, great demo. And just to kind of summarize that when you're managing a growing and changing environment, that the outcome of having intelligent analytics that are going to help you manage these decisions all the way through the stack of application resource management, that it assures a good performance of your service, a good experience for all of your tenants, because these are actions that can be taken through the stack. They're preventative, plus give you visibility to each one of the tenants in your clusters. helping you manage this complexity at a rapidly changing scale. Let software make those resource management decisions that are automatable, actionable, so you don't have to have human beings trying to guess the right size, guess the right number of placement decisions. And ultimately, this can help your business accelerate the adoption of cloud native and microservices and get that business benefit that brought you on this journey to begin with. And Lynn and I would like to make a shout out to one of our business partners here, IBM Red Hat. Excuse me, we've had a strong partnership for 3 years now that started out with a blog that Enlin wrote, self-managing OpenShift with Turbonomic. We're a prime partner, certified solution, even proud member of Operator Hub. And we did a webinar with Dan Jungst from Red Hat a few months ago. And for those that out there that are thinking about how does this fit into my day one, day two operations of managing containerized platforms, we fit very nicely here into that operate area. And it is about not just visibility, but about automated actionable decisions that help you assure performance while managing the trade-offs of efficiency and compliance. And I think with that, Enlin, do you have anything else that you'd like to add?
No, I would love to hear some questions. If anyone has any questions, feel free to ask. That's
right. Please definitely go to the Q&A and chat area in the session. We'll answer those right now. I know that we've been answering them as we can. And thank you very much, everyone, for participating. And stay safe and have a great day.